We are Group 9, and the title of our project is Predicting Monthly Labor Hours Based on Workload Demands. And I'm Lauren Fontaine.
I'm Blake Ferguson.
Dylan Israel.
And I'm Molly Jacobson.
Our Lady of the Lake is a regional medical center located in Baton Rouge. Management has been concerned about the fluctuation of labor needed for different uncontrollable reasons. The hospital would benefit from an equation that would predict the needed labor hours and thus the staff needed at the hospital. The team was given data from 30 different hospitals showing how labor hours differed based on 6 different independent variables, which are average daily patient load, monthly X-ray exposures, monthly occupied bed days, eligible population in the area, average length of patient stay in days, and if outpatient services are available. The dependent variable being the monthly labor hours, and the project is significant because the team is providing a level 2 trauma center with helpful insights that could save the hospital time and money. It saves management time in calculating how many hours are needed for labor, and it also saves the money by not overstaffing because their lack of knowledge of effects of the workload on labor hours.
Based on our descriptive statistics found and these graphs shown, we can see a linear trend between our X1, X2, and X3, while X4, X5, X6 did not show a real linear trend. So going forward, we're going to need to investigate our X1 daily patient load, our X2 monthly X-ray exposures, and X3 monthly bed days, and how they relate to monthly labor hours.
Our first step in creating the regression model was plugging the data into JMP and running a simple linear regression model within the fit model function. Here on the screen you can see that our R squared, which is our indicating if the model is a good fit, is 0.99, which is a great R squared. Moving on to parameter estimates, we see that X2, X3, and X5 have probability t-values less than 0.05, meaning that we reject the null hypothesis if they are not significant. We are going to move forward with other analysis to see if any variables can be removed from the final equation. Next, we performed a forward stepwise regression also using JMP. Our stopping rule was our p-value threshold. We chose 0.1 because we felt that was a good p-value and alpha level for degrees of error. Looking at the current estimates, we can see that X1, X2, X3, and X5 were deemed significant. Therefore, we then looked at the R squared, the summary of fit, showing it was 0.9924, which is a very good fit. Therefore, we decided to generate the prediction expression shown all the way to the right. This is the final expression that was given to the hospital.
In conclusion, there was one main limitation that we had for this project. Unfortunately, for the size of the data and the sample size that we had, we felt that it was too small, and that given more data, we'll be able to provide a more accurate formula for staffing each day. There were 4 main variables that we used in our correlation formula. However, there were 2 that stuck out the most. The variable with the highest correlation affecting how much staff will be needed on any given day is average daily patient load. And the second most strongly correlated variable was number of X-ray exposures. This correlation is due to the fact that as more X-rays are needed, the more staff and hours are needed to conduct these X-rays. Thanks, Dr. Chun, for a great semester. We look forward to seeing you around campus, and go Tigers!